Okay. Right. Now see, you can see this. This is a normal program for the vector. In last lecture, we have seen how to just declare this vector. So this is the container name. This is vector. Then whatever is the type that just we wanted to use for this, that we can mention here. And v is, we can say, that is a kind of object. Okay. And consider this is an array. As I said that vector is a dynamic array. So now we consider, suppose only 6 elements are here into this array, and how we can display these elements. So this is the code, we can say, right? So without using iterators also we can display this vector elements. So I'll show you how we can do this. I'll just copy and paste there so that I'll just minimize this time. Okay. Here, sorry, I need to copy only this. Okay, and here I'll just include bits. Right. So see, this is the normal way of just writing the program for the vector. So here 6 elements are there in this vector, and I just use this for loop and just use this size for that size of that vector, and we can display the elements first, second, third, and something. If I run this, let me see what will happen. You can see here the elements are displayed. Okay. Now see, without the using that iterator also we can display these elements. Same thing, we can do this in the array. Without using pointer we can display the elements of that array, and with using pointers also we can display the elements of the array. Now here, so as we are studying that iterator concept, so I'll just tell you how to create that iterator first. So with this code we know this is the output. Now I'll just try to use the iterator here. Now see, I'm just creating that iterator of type, because we are having that integer array, and this double colon, or we can say scope resolution operator, that is required over here, right? And you just use this term iterator, and you can use that name of that iterator, right? Or suppose I'll just use that IP, right? This one. This is the syntax. Now see, oh, I just check whether it's, see. So when what happened for this, I don't know. I don't know. This is not working. 1 minute. See, suppose this is the array with some elements, right? Now here 0, 1, 2, 3, 4, 5, 6, 7. These are the locations, we can say. So whatever is this location, this is begin, right? And this we can say here, this is the end. Now see, begin of this vector we can say, and end of this vector, this is v dot begin is the first element that is pointing to the 0th location, and whatever is the v dot end, that is pointing to next of last element. If suppose there are 7 elements are there into the array, so whatever is this v dot end, that will point to the next to last element, and this v dot begin, that will points to first element, that is the zeroth element, you can say. Now in this case, whatever is this it, we can consider this as a pointer. This is used to store that address of another variable, we can say. So here it, I'm just initializing to begin. Okay, this one, it means that it pointer, that is pointing to the first element. And now suppose I wanted to display this, normally we use this pointer concept in C or CPP, and suppose endl. Okay, so what would be the output of this one? Sorry. See, with this code, this 1 2 3 4 5 6, that would be printed. And if I'm saying here, so I am printing that value of it, and it is initially assigned to the first element over here. It means this it will points to the 1, that one element, you can see here. So if I run this, so that output would be 1. So if you see here, you can see this output is for the previous code, and whatever code I have just written over here, for this code, that output is 1, right? Suppose I wanted to print that second element, then how I can print it? I can see, just copy the same thing, and simply I can say this is +1. So this will be printed, that second element, whatever is the 2, that 2 will be printed here. So you can see here, this first 1 2 3 4 5 6 for the previous code, and it, this is 1, it plus 1, that is second. In this way, if you continue this, it is it plus 2 suppose, so that next element will be printed, that is a 3, right? So here in this case, we can see this is it, then this one is a it plus 1, then this is it plus 2, likewise, right? So initially that v dot begin means at the zeroth location, so that same element will be pointed to the zeroth location, and that will be printed because we are using that cout statement. When we say it plus 1, then second element will be printed. When we say it plus 2, next element. If we say it plus 3, next to next element, right? So in this way we can print this one. But now see, this is okay if you are printing single element, but suppose I just wanted to use any loop into this, so how I can do this? So here I'll just replace this with this loop for it dot, sorry, it equals to v dot begin, that is the initial condition, then it is not equals with v dot end, right? And now here I can say it plus plus, and we know to print that iterators we can have this star it, right? Just give some space over here, and I can run this. You can see whatever are the first 6 elements, these 6 elements are for this code, whatever the code I have written. And without iterator, this code is there, and if I'm using that iterator, so this code is there. Using the same code, we have printed the array element or vector element, we can say, right? So this is the syntax of this one, right? Now see, suppose I just wanted to change that value of that array, because in that array or vector, so 1 2 3 4 5, these are the some values. Now I'll tell you what will happen if I just do here. Sorry, 1 minute, 1 minute. Assignment is, hmm. So I'll just use this. Okay. Now just I wanted to change that IT plus 1. So I'll copy this. Suppose I am doing this like IT plus 1, right? Here I just wanted to change. This is plus plus. It's increment, right? So this code, whatever the code I have written here, that is for the without iterator. I can print that same vector. This one is with iterator. I can print the same. And what I am just trying to do is whatever are these values. So in all these values, in this, I just wanted to add plus 1. But see, that main thing is here, whenever we use this kind of the statement, so whatever are these values, these are the from that vector container, these are getting copied, so original value is not getting printed over here. Just see. So when I just run this, you can see, I'll put this end statement over here. You can see here the first output is for the without using iterator, second is with iterator, and the third one is what we just added 1 to these values. You can see here, right? And this is, we can say, kind of the call by value. Okay, so I just tell you the what is difference between the IT plus plus and IT. Now see, suppose this is the array. Today actually I do not have my laptop, so I don't have the much idea about this. I am using my fingertip to this, right? So 0 1 2. Now see, suppose some elements are there, this one, right? Now see, if I just use IT plus plus, that meaning of this is it goes for next iterator. Next iterator. And if I just use this IT plus 1, this goes for next location. That pointer will goes for next location. Now I'll just tell you the difference, because if I just use this vector container, in that case next iterator and next location both are same, because this one element is the suppose current location. So whatever is the next element or next iterator, that is the 2, and also that next position or next location is 2, right? Because this is in consecutive manner, right? So that vector is in consecutive manner. That's why next iterator and next location both are same. But if suppose I am using such kind of the thing like the tree graph or something, so in that case the memory locations are not in consecutive manner. These are like this, right? Suppose this one is the thing, right? Now see, if your iterator is pointing to this IT, so if I say IT plus plus, so what I said in this IT plus plus, if I say this IT plus plus, so it is going to the next iterator. It means this is first iterator, suppose this is next iterator, or this is the next iterator, and for this is the next iterator. Now when I say IT plus plus, so this iterator will goes either to this or to this depending on the condition. But if I say, this is in case of IT plus plus, if I say IT plus 1, so in this case what I said into this will go for the next location. So here see that 1 2 3 4, all these are not in consecutive manner. So when I say IT plus 1 here for the 2, so that pointer will goes to the next location of this one, and this is not valid. This is not valid because we need to pass that pointer to the 3, but it is going for the next location. So this is not valid and that program will not run. So that's why if you are using tree graphs or something, so in that case we cannot use this IT plus 1. In that case you need to use this one, because if you see the meaning of that IT plus plus and IT plus 1, that meaning would be same in the C and CPP programming. But when we consider that iterator, so in this that meaning is different. This meaning is it is going for the next iterator, and meaning of this is it is going to the next location. That you just keep in your mind. In vector, that next iterator and next position both are same, so that's why that will not affect much. But if you see that linked list, graph, trees, in that case, so this will get effect. Okay, so I've understood this. So here you need to understand how to create that iterator, right? And how I can use it. So here the main the functions are two, that is begin, whatever the container name dot begin, and that container name dot end. So you can use these begin and end in the for loop, and whatever is the iterator you just created, with that you can print the entire vector, right? So these are the two things. Okay, now I just move for the next one. See, if you see the syntax of this for loop, then it's becoming somewhat longer, so we can reduce that syntax also here. So for that we have one that range based loop, so we can use that range based loop. Using that range based loop we can reduce the this length of this for loop, right? So I'll tell you how. First I just delete this one. Now I'll just tell you what is that range based loop. So here you can write for, then int value, right? And here we can put the name of that container. So whatever is this one, these two, right? These two lines are there to create that iterator. So first is this vector int scope resolution iterator and then it, right? Then this for loop. So if you are using this range based loop, so we can replace these two lines with simply that small line you can see here. And here simply I can print value, whatever is that variable we just created here, this one, right? And same thing, now I'll just run this program. See, this this code and this code, that working of both is same. Only here we have created this iterator with this syntax and with this for loop. This is a bigger one, so we can replace this entire thing with this only. So I just run it and we'll see that whether that output is same or what. Yes, that output is same. I'll just see here. It is taking time. So whatever that output will be printed. So without iterate compilation terminal, what's happened? Okay, I'll run it. You can see here, this first output is without using iterator. Second is using the syntax. So this is somewhat longer syntax. And if you see that third output, so we have just used that range based loop. This is the range based loop. So this whole thing, this is not required. And whatever is this loop, again, instead of that, we can use this short loop only. And with this, we can print it, right? And this kind of the output is, we can say, the call by value kind of, right? You've understood this? This is a range based loop. Okay. One minute, I'll show you that. One more thing I'll just tell you here. What I'll do here, oh, here, just I'll tell you what is the difference between that call by value and call by reference. So we'll understand with the example here, because see, whatever is this, the vector, in this case simply we are copying it, we are not actually the accessing these numbers, we are simply copying into that value and we are printing it, right? So I'll tell you how it happened. Suppose I am using this v, right? And here what I'll do simply, so here already we have, I think, yeah. Okay, so what is the expected output into this? You see here, what I'm just doing here, whatever are the contents of this vector, like 1 2 3 4 5 6, I just wanted to change the value of 1 to 2 because I'm just incrementing this. Then second value, that is 2 to 3, then 3 to 4, 4 to 5 something. But if I just run this one, as I said, it is not actually accessing these elements, it is just copying. and after copying into that value, it is performing the operation. It means whatever is your original vector, that is not being changed. So if I run this, so output would be same. You can see here 1 2 3 4 5 6, again here 1 2 3 4 5 6, and here also that same, right? Now how I can change this one, how I can access these the elements directly from the vector. So for that, we know, if I suppose simply put here that address, the symbol here, and if I run this, so whatever is the output, that 1 2 3 4 5 6, that will be changed to 2 3 4 5 6 7, right? So here if you see, you can see here the first output is without using iterator, second is using this syntax of that iterator, and third one using the range based loop. So here what I did here, I'm just directly accessing these vector elements using this, right? So and value I am just doing here so that I can access directly these elements. So whatever is the value of first location, that will be changed by 1, means added 1 into that. So 1 to 2, then second value again 1 will be added into that value, so that becomes 3, and in third again it will be added 1, and that becomes 4. So like this, 2 3 4 5 6 7. So if you want to access directly these elements, you need to use this syntax. Okay, have understood this? So this is the one thing. Now again we can have the second thing. Here we need to assign one or begin or end something here. So one more keyword also there, that is the auto keyword, that also we can use, that auto keyword. So if you are using that auto keyword, then here not necessary to say anything about the whatever the syntax here, vector, int, and something. So automatically it will consider the type of that vector, right? So that again I'll just tell you here. Now I think if anything in this the range based loop, you can ask me. So this is very short, the loop we have just used here. Instead of this long, we can use this short one, right? If anything, you can ask. Otherwise, I'll just tell you that about the auto keyword. So when I just use that auto keyword, I'll just delete this so that you will understand. When I just use auto keyword, so whatever this statement we have written, that is not required. Why we have written this statement? So we need to know which container we are using, the type of that container, then iterator with the type, right? That we need to know. But if you are using suppose auto keyword, then with that, whatever is the container type, that will be considered automatically based on these values, whatever the values you are adding into that. So based on these values, that container type will be decided. So how I can do this? Simply you can use that auto keyword here, auto, and then whatever is the initialization, begin, then IT plus plus, right? And here simple, whatever is a statement, that statement I just write here, that is star IT. Okay. So here I need that cout statement again. You can see the purpose of both is same, but here again, if you see this syntax, so in this syntax also 3 lines are there, and if you see this syntax, so only 2 lines are there. So here whatever is this line, that we are not added into this. So if you run this, so output would be same. You can see here. again same thing. I'll just rerun this. You can see here. So 1, 2, 3, 4, 5, 6, that output without using iterator. Second is again using this syntax, right? So that iterator, that output would be same. And if you are using suppose auto keyword, we just minimized, or we can say we just excluded this line. So again that output is 1, 2, 3, 4, 5, 6, right? So in these way you can use the iterator, right? So you can use iterator for all containers, that you just keep in your mind. So only for vector I just told you here, but for other like list, stack, queue, whatever the containers are there, for all containers we can use iterator. So iterator is what? This is nothing but a pointer, that you just understand. Because whatever is this syntax I just told you, so this is without using iterator. Because when we see that array concept, so without using pointer also we can display the elements of that array. Using pointers also we can display the elements of that array. That same thing I'm just telling you here. Without using iterator, it means without using pointer, I can access the element of that vector. With using iterator, again we can access the element. So actually this is the most important. Whatever the 2 points I just told you, that is added, we can say here. So these are not mandatory, but this whatever just I just selected here, so that is the mandatory here. At least you need to know this one. If you want to use that the range based loops, that is okay. That will just reduce the syntax of this one. If you want to use that auto keyword, again that is okay. That will reduce that number of lines here. Only that one line would be decreased here if you are using that auto keyword. That auto keyword, that is used to decide the type of that number. So if you are assigning suppose 1, like here suppose here you said auto a equals to 1, then that a will be treated as a integer. If suppose you are saying a is 1.5, then this a will be treated as a float, right? So in this way, so whatever is the type of this a, that type will be decided based on this input. If you are using suppose auto, right? If you use this auto keyword, so the type of this variable will be decided based on the value you just assign. So that same thing I just told here. So this statement is for what? This statement is for deciding the data type of that iterator, this statement. But as we are using the auto, so here, so this statement is not required. Simply you can write the rest part here. So this will consider automatically whatever is the type of that iterator, right? And that iterator type is based on that container type. Okay. So if anything you can ask, I'll just show you in short the PPTs. Whatever I just told you, that the same thing is there into the PPT. I'll show you quickly this everything I just explained here. So from here I'll just tell you. You can see already I just told you. Suppose these are the containers elements we can say, right? So to point these containers, we need to use the iterators. So here this example is what? This example is without using iterator. Simply we just use the container, and using the simple the code we have just displayed this element suppose. Now we can use the iterator. So the syntax for this is this one. So we have created iterator, and the type is this, whatever is the return here, and we can assign that initial value to the iterator. So this value we can assign here. So it equals to v dot begin. So that would be the initial value here. And as I said, how do I access these elements? So we need to use this one, right? This one. With this, whatever is that it pointer, that will points to this first element, that is to the 1. and same that I am just printing here. So using this statement, so that first element will be printed. Now suppose I just wanted to print the second element. So here what I did, it plus 1, it plus, actually I just did here 3, right? So it should be 2, but anyway, so it plus 1, this is first element, second element, it plus 2 is next element. Now see here, the difference I just told you, the difference between it plus 1 and it plus plus, as this is a vector. So here it plus 1 and it plus plus both are having same meaning, because that vector is in consecutive manner, right? But if you are just going for the linked list tree or graph, so that this it plus 1 will not be workable. Instead of that, you need to use it plus plus. Okay. So this is with, I have not used any kind of loop here, just I just told here how to access these elements using this iterator. Now here I have just used this iterator. Okay, so this syntax, this loop, that loop syntax that we know, that is the initialization, then condition, and then increment. So this is the initialization, this is the condition, and this is increment. And simply I am just using this it iterator, I am just printing the entire array. So this same array I am just printing over here. So you can see here in the output that 1 2 3 4 5 6 and 1 2 3 4 5 6. Now next, using this also, as I said, it plus plus and it plus 1, that output would be different. Here I am just adding plus 1 into the iterator value, right? So here with this, that output is 1 2 3 4 5 6, and if I am just adding plus 1 to the values to the vector, then it will be incremented by 1. So 2 3 4 5 6 7, right? Now already I just told you what is the difference between the it plus plus and it plus 1. So it plus plus, that will points to the next iterator, and it plus 1, that will points to the next location, that you just keep in your mind. So here this one. Okay. Now this is the normal iterator, we can say. If you just wanted to use this range based loop, so consider this is a program, and I just wanted to replace this segment with this range based loop, this segment. So how do I replace this? You can see here. So this is that segment, and I just replace this with the small code here. Only this is the small code, that output is same, 1 2 3 4 5 6, same here, same here. This is a one code, this is second code, and this is the previous code without using iterator, right? So just I told you something about the range based loop. So range based loops are used to shorten the loop statement and body of loop. Already I just told you. You can see here the length of this loop and length of this loop, right? So it gets shortened. Then in range based loop, value of container becomes a copy. It does not use actual value, like in example, whatever the example I shown you, in variable value. One gets copied, one is not the original value. So here in this, whatever are the values are coming into this value variable, so these are simply copying. So this 1 will copy here, then 2 will copy here, then 3 will copy here. It means into this, if I increment, suppose if I add 1 to that value, so 1 will bring into this, and then it will be added 1. So that becomes what? If you are printing this one, that value is incrementing here, but that value is not reflecting into this, because original array we are not changing this, right? So when do I change this variable original array? If I use the reference one. So see here, for int value colon v, if you just use here ampersand and, so you can see this, then whatever is this array that will be originally changed. You can see here in the previous case that output is same, and in this case that output is been changed, right? So also I have just written over here, here output does not get changed. So to do this we need to use reference, right? So this is the range base. Now next one is the auto keyword. So as I said, so it automatically predicts the data type from assign or given value. Like here you can see, I just told you the data type of A will be decided based on this value. If I just assign that 1 to this A, then the data type will be integer. If in second example you can see here, if I assign that 1.1.0, then that will be considered as a real or floating value, right? So compiler automatically consider A is an integer as assigned value is integer. So here if we write this one, then it assume A is an real variable. So it means, so we can shorten the declaration of iterator here, not necessary to include this statement. Already I just told you here, in this case whatever is this statement is not required. Sorry, here I shown you, here you can see, so whatever is this first line here, that is not required into this one, right? So instead of this statement we can include only auto keyword, right? So this is the sample program, we can say this is sample, because whatever is the value assigned to this A, that will be printed. In previous case 1 will be printed, here 1.5 will be printed. If you assign any kind of string here, so that string will be printed, because that auto keyword we have used, and that will consider the automatically that type of that A or that variable, right? So this is about the iterators. So if any doubt into this iterator, you can ask me, because these iterators we can use in all container. Today we have seen how we have used this iterator into the vector. So in next lecture, I'll just tell you how we can use these iterator into the list, tree or graph something, right? So this is about the iterator. If any doubt into this, you can ask me. Only one thing you just keep in your mind, iterator is nothing but the pointer. That you just keep in your mind. If you can compare that the normal C++ programming and this STL programming, so in normal C++ programming we are using pointer specially, right? And here we are using the iterator, so to point the values. So that is only difference here. And the other thing here, if you are using iterator, so that program becomes simple and shorter. That is again a benefit of this iterator. Okay. So in next lecture, I'll just try to tell you some containers. Now see, the syntax of all these containers are fixed. So I'll just take 2-3 containers and just tell you how these containers we can use. Again, in these container, the functions are ready-made functions. Inbuilt functions we are using, there is no change in these functions. We can keep that syntax as it is. Everything we can keep as it is. So that's why I'll just tell you the few containers, or so REST containers you can use. Only that syntax you need to know in all these containers. Only if you are using container, so we need to know how that program can be written without iterator and with iterator. So without iterator, that vector container we have seen, and with this iterator also we have seen this container, right? Now next container, that is a stack, queue, linked list. These containers I'll just tell you in tomorrow's lecture. So these are again simple containers. Only for that you need to know something about the basic of these container. Like array, that is very simple, because everyone knows, everyone is having idea about the array. What is the format of that array, that everyone knows, because all these elements are kept in the consecutive manner into the array, whether that is a dynamic array or that is a static array. In both cases, that arrangement of the element is fixed, that is in sequential manner, right? So this concept that we know. But if you are going for the linked list, stack, queue, so you need to know the basic concept of that stack, queue, linked list and something. If you understand that concept, then whatever the operations we are performing, these are the inbuilt functions. So using these inbuilt functions, we can perform the operations, right? So that is not the big deal. Only you need to know the concept of that one, right? So this is from my side. If anything you can ask, right? So I'll first stop this recording.